Hi, welcome to the session about citation impact measurement, which is part of our training series. Before I start, I have a short disclaimer to give. So basically, this session and tools discussed here are intended solely for experiences sharing purposes. The databases and indicators referenced are not exhaustive, nor are they meant for endorsement. So in this session, I'm going over some of the indicators and also vendor databases to give examples. But I know that they're not exhaustive, and I also do not mean for any kind of endorsement. It's simply because I'm using these tools, so I think that it's easier for me to use them as an example. Okay. My agenda today can be represented in sort of a graph. So I'm going to start from very broad about the research impact, and then something smaller about academic impact, and then something even smaller about citation impact. For those of you who are familiar with the term citation impact, you know that there is something even smaller within that, because there are several different ways that you can count. So my smallest circle today is the citation impact indicators. And you can also see that this would be the general picture that I will be describing today, starting from the biggest one, the broadest one, and then narrow it down in several different ways, and then to conclude at the part of citation impact indicators. And because the session is also to help you to do the real analysis, I'm also going to tell you how exactly we use these indicators in our report and how to really do that. All right. Okay, so the first part about research impact. The term research impact has been used a lot in Europe, and it has been developed for a long time. Based on their definition, it means that impact is the good that researchers can do in the world. So it sounds very broad, and it can cover actually a lot of different things, okay? But generally, what you can see is that there is something about academic, solely on research. Okay, there is also something about non-academic that is not that academia. There is also something about direct impact. There's also something about indirect impact. For direct impact, it's pretty straightforward. For example, if you do research on topic A and somebody else is doing the same research, they found your research and they think that it's really good, so they want to follow up on that, then your research has direct impact on them. Okay. Indirect impact. I would like to use bibliometrics as an example. So a lot of the time when we do bibliometric analysis, we have to provide these results to the end users. And the end users can be either administrators or maybe directors, program directors, or any analysts who would like to know the performance of specific research. Okay, and after they read the results, they may realize that there is a lot that they can get from bibliometrics, and there is a need for more people to do this kind of analysis. So they may want to hire more librarians or people who work on bibliometrics. So in a way, they create the demand for librarians who work on bibliometrics. So this is the kind of indirect impact that we provide when we work on bibliometrics research. Okay, so again, this is just a quick example. All right, so let's move on and talk about the types of non-academic impact. There are several different types of non-academic impact, but some major ones include economy, say for example, how we spend money. Do we have different trends in the way we spend money or buy houses. Okay. Maybe we have impact on society, on specific social norms. Do we value diversity more or equality more? Okay. Maybe we have impact on our culture, maybe like food culture or religion. Okay. Or maybe we have impact on public policy, services, or the environment, or the health, well-being about the lives we saved. So there are a lot of different things people can measure as non-academic impact. Okay, but focusing on what we're going to talk about today, I have to focus on the academic impact. By definition, it means that it's an intellectual contribution to one's field of study within academia. And by looking at intellectual contributions, we can think about a lot of outcomes from research. Okay, we can focus on teaching, mentoring, or training. We can look at the fundamental concepts resulting from our research. We can also focus on the development of tools or prototypes from our research, or maybe some products or processes or services coming from your research, or awards or grants that you got because of your research. So there are a lot of things that we can say that they are the contributions to your field of specific study. But then it all circles back to the question, what exactly are accountable? Because we would like to see how exactly we can evaluate academic impact. Qualitatively, we can look at the peer review. There are a lot of peer review being done to assess academic impact, okay? And quantitatively, we look at a lot of different numbers, the numbers that we would like to measure. And that circles back to the question that I raised earlier. What exactly is countable regarding the things that we would like to measure, especially those outcomes, those contributions? So let's look at our contributions again. There is a part about teaching, mentoring, training. There is a part about the concepts that you created. Okay, there are the parts about the tools or the prototypes that you developed, or the products that you invented, or the grants or the awards that you received. Okay, and what exactly is countable? How many of them can be quantified? If we look at teaching, are you looking at how many students you have taught? Or are you looking at a specific teaching style or a teaching philosophy, or the kind of students that you help to reach their goals? Okay, so how many of them is countable or can be quantified is a big problem. Okay, and even when we look at the things that can be counted, there are still different ways to do the counting. Okay, so a lot of times when we look at impact assessment indicators, we face a lot of strengths and limitations as well. Okay, some of the major strengths, of course, include that it's very convenient because there are so many numbers that we can look at. Okay, and it also provides easy evidence because we can use those numbers to do comparison easily, and it is less time consuming. And there are a lot of limitations. The first one is, of course, that there is the continuing battle between quality and quantity. How do you find the balance? And how do you really know that the quantity that you found really support the quality that it should have? Okay. It also produced the problem of goal displacement. So a lot of the time, people would think that, should I produce research, good research, or should I produce research that would be ranked as good? That can be different depending on how we rank the research. Another possible problem is that people can always game the system. For example, if they know that some schools or programs emphasize specific journals or emphasize specific topics, they're going to think about where should I publish or what should I publish so that I can win or get more credits or get more scores, okay? And people also tend to focus more on the mainstream trends because these are the trends are the things that they can easily get higher scores or being quantified, okay? And of course, that can change the whole hiring and promotion strategy. Say, for example, remember one of the contributions is about teaching, but if a specific school or program does not care about teaching at all, then the researcher can say that if teaching is not important to me, I'm not going to spend much time at all in improving my teaching. He may just focus a lot more on getting his research done or pushing his publications out instead of trying to teach more in the classes or to transport what he has learned to the next generation. Okay, now we have to go to the part about citation impact because it is one of the ways that we can look at the citation impact. Okay, so for citation impact, two major assumptions is that we think citations are recognized as a proxy for quality. So it's a proxy for quality, okay. And the second one is that it's being used to assess research performance. So basically what we say here is that we use citations to measure research performance, okay. And you can see that there are a lot of problems based on this specific assumption here. Let's see an example of a citations. Okay, so this is a paragraph that I just got from an article. Okay, and there are a lot of numbers here, so you can see that there is a sentence that's being said, and then the researcher uses 3 citations to support what he said, and then use a lot more in this short paragraph talking about what has been done and use things to support what he said. Okay, so one of the questions that we see is that we don't always know why people cite. There are a lot of different reasons when people cite something. But when we just look at the citation count, the number, we lost the context or the background. So Garfield has a very good article about why do people cite in his very early article in 1964. He listed a very long list of reasons about why people cite. Basically, it's to give credit or to correct someone's work, or it's because that you're going to criticize something, or you would like to provide background or to identify some important publications that is related to the concept that you're going to provide. Okay, so these are all positive. Okay, but there are also times when people cite something, it's because that they actually would like to disclaim some work or dispute the previous works. So basically, it is something negative, but you won't be able to know when you're doing this counting, these numbers. Okay, so are we going to treat them all the same? Or the question should be that, do you think that it is appropriate to treat all of these numbers the same? Okay. Okay, so how do we measure? The first one is just by counting. Okay, no matter how that article is being used or referenced, we count them. Okay, and the second one is that by normalized calculation. So basically, this is about the citation, okay, the number, we count it, and then another way is probably to normalize it somehow. Okay. There are other things that we can look at that is not about number, but about the research that cites our research. Say, for example, we would like to look at the different types of a publication. Are they guidelines? A lot of the time, they are kind of like a policy. So if they cite our research, we can interpret as a way that our research informs the policy. Okay, or maybe patents or clinical trials, do they cite our research? We can use that as a way to say that our research informed maybe the industry or the health field. Okay, or we can compare our original article with the citing articles. We can look at the research topics. Do they expand? My research is on bibliometrics. But when people cite my research, maybe they're in the field of, say, bioinformatics, or maybe in social behaviors. If that's the case, we can say that the research topics expand to different fields, meaning that we have impact in other fields. Okay. We can also look at the research by looking at the co-author's affiliation, geographical area. By looking at that, we can say that the research either stay or maybe extend to different areas in the world, so that we can say that we really have extend our impact to different parts of the world. Okay. All right. As we mentioned, that the major way is actually to look at the number, the counting, and we have also talked about the problems of counting. Okay, the first one, of course, is lack of a context. It's just like when you're searching on the Google. You don't really know what is the best one. Sometimes even when one got a lot of a bad review, it can be popped in the very beginning, simply because it got a lot of a bad review. And same thing for citation. An article can be cited tons of times simply because it's bad or some mistake that it made. Okay. Another limitation is that it is only a proxy of scientific impact. It is just an estimate. It is one of the ways. It is not everything. Okay. Another problem is about full counting versus fractional counting. If we're only counting the number of reference or the citation or the article, it is fine. But a lot of the time, we are looking at the contributions from the co-authors. So for each of the co-authors, are you giving them the full credits at all? Or are you going to give them fractional counting? So right now, there are a lot of group authors, and a lot of the times there can be hundreds or even thousands of authors. So how do you give them the right credits in this kind of accounting? Okay. There is also the problem of inaccurate attribution. So basically, this is the mistake in citation, giving them the wrong credit. Okay, so they don't really say what they mean, and they don't really support what you're going to say. There is also the problem of incorrect citing. So a lot of times there are errors. Okay, they use either there are typos or there are some sort of errors in the references. Okay, and research has found that more than 1/3 of biomedical journals articles have citing errors. And finally, there is the part of embedded limitations about citations. And we have talked about the limitation of citations earlier in our sessions. So I'm just going to quickly go over it again so that we can move on. Okay. So this is kind of like a refresher talking about the traits of citations. As we mentioned that there is always the distribution difference of citation, and it is not normal distribution. So for citation, for any given field or any given journal or even any given author, what you find is usually this kind of a power or a log distribution, meaning that 20% of the publications receive most of the citations, and 80% of them receive very little to non-citations at all. Okay, so this is the first thing. The second thing is that citations have different, have the field difference. So here you can see that there is a huge difference between neuroscience and humanity, or even in health, or even between health science in the middle. Okay, so you can see that some of the fields have higher frequency in publication, and they have a longer list of references. They have much more co-authors. Okay, meaning that they are more likely to get more citations. And for other fields, because they do not publish more, have so many co-authors, and they do not cite too many people or too many works, they basically give fewer room or a little room for people to cite. They also produce fewer work for people. They produce fewer works for people to cite, and in their works too, they cite fewer people. Okay, so because of this nature, you don't want to compare their citations or the times of their work being cited. And when we put these two traits together, we'll know that whenever we would like to compare citations, we don't want to look at the raw number. We don't want to look at the average. We don't want to just do the comparison between these fields without doing any normalization, because the raw number can be very different. Okay. So that leads to the smallest circle that I'm going to focus on today, which is about citation impact indicators. We have talked about the non-normalized indicators in our previous sessions. Okay, so there is a part about publication count, and then there is a citation count. There is the mean or average citation. There is a journal impact factor, H-index. They are non-normalized because they basically use the raw count. Publication count, we just count how many publications one specific research or office or lab produced. Citation count, again, we just do the counting. Mean citation, basically it's the citation count over the publication count. But again, as I mentioned, that there can be a lot of a problem when you want to do the comparison. Okay, there's a journal impact factor. Basically, it's kind of like a distorted average citation count. All right. There is also the H-index, which you're going to find a number for the, if you're going to draw a graph, you have to find a number in the 45-degree line, meaning that you need to find a number that you have the same number of publications and the same number of citations. Okay. So basically, all of these indicators have the same limitation. Okay, and the same limitation is that they do not consider field difference. Remember, we talked about the field difference in all of the different fields. Some can have more citations or more publications. Some will have fewer publications and fewer citations, right? So if we would like to compare these groups, we would have to use some different methods that consider field difference. Okay, so that's why we have to look at the normalized citation indicators. These normalized citation indicators are developed to account for specific things. First, about field difference. Second, time difference. And then third one is about document type difference. Okay, so I'd like to share you with some of the examples. Okay, so two of the examples are journal normalized citation impact or category normalized citation impact. So the snapshot that I show here is something that I got from Insight. Okay, so you can see that on the top here, you can see the author title, the authors, the source, which is the journal title, and their research area, and then the information about the publication date, time cited, and a lot of other things. And these are the two indicators that I have listed here. Okay, category normalized citation impact, journal normalized citation impact. You might wonder what they are and how they're being calculated. Okay, so the calculation is that for all of these expected citations, basically they mean the average number of citations. So you're looking at some sort of an average. Okay, so it is the average number of citations to articles in a specific year and field, or in a specific year and journal, or in a specific year and document type. Okay, note that we're focusing on specific year and field because we would like to compare things that are very similar, that have the same condition. Okay, so basically, this is how they calculate those normalized citation score. We have the citations of your specific article, okay, and then we compare your citations against the expected citations. All right, so let's go back to look at the thing that I have just shared with you. Here is the part about journal normalized citation impact. And how we get that is by looking at the time cited, which means that this is your citations, and we use that, okay, to be divided by the journal expected citations. So this is 2,000 something divided by 340. And that is how we got 6.3 as normal journal normal citation impact. And of course, we can do the same thing for the category normalized citation impact. We use your citation divided by the category expected citations, and you will get this number, 36. And how do we read the results? How do we interpret that? Basically, it means that compared with the average citations in the journal, your citations are 6.3 times better than the average. Or you can say that in a specific category, your citations are 36 times better than the average publications in this category. So this is how we interpret that. Okay. All right. There is another normalized indicator called RCR, or Relative Citation Ratio. This is a new metric developed by the NIH OPA office, and there's an article published in 2016, which you can get from the link here. And it's housed in iCite. So basically, publications need to appear both in PubMed and Web of Science from 1995 to 2018 to be included in iCite. And the RCR score are available for publication published between 1995 and 2017, which sort of makes sense because publications have to be at least 2 to 3 years old to gather enough citations to do analysis. So their cutoff point is kind of like just 1 year, 2017, okay, which is kind of generous. All right, so this is relative citation ratio, okay, and what it is that they're actually looking at similar things. They look at your citation and compare with the average of a co-citation network. Okay, so how do we look at the co-citation network? So here you see the red dot, okay, the red circle here. Let's say that the red circle is your article. Okay, so there is an article. Okay, so this is your article, and the orange one are the articles, the references that you put in your article, okay? And the blue one are actually the articles that cite your articles, so the citations that you get, okay? And they can cite other articles as well. So here we form a co-citation network, all right? So basically what they do is that they pull out the citations of all of in this co-citation network and find their average. Okay, they compare your citation against the average of this co-citation network. And after that, they benchmark this number against NIH-funded research, and then they will get the number. Okay, it's a little bit complicated, but basically this is how it works. And once you get that number, you will be able to say that your publication is how many times better than the average of the co-citation network, okay, or the NIH-funded publications. Okay, the strength or the advantage, of course, is that it adjusts for the differences in the fields, okay. It compares your research against something. Okay, the limitations of it is that now you know that the field is a co-citation network, but you don't really know what exactly the research subject category is. So you won't be able to say that my research or my citation, the citations that I receive are 5 times better than the average citations in the field of epidemiology or biochemistry. You won't be able to say that because you just don't know what kind of a subject category it is. You only know that it is a co-citation network. Okay. Another problem is that the documentation is not that clear. We are still not quite sure what kind of a citations resources are being crawled. Okay, so we don't really know where they get citations, meaning that you can get different results, different citation number from iCite and from Web of Science or Scopus. All right. Another type of normalized indicator is percentile ranking. Okay. And I believe that all of us are very familiar with percentile. We see that a lot from maybe SAT, from GRE. So you know that when you're a 99 percentile, you're the top performer. Okay. So we want to know why we use percentile. So first of all of the previous mean or average-based citation indicators are still strongly influenced by extremes. So if we have something that is very high or very low, you can get influenced. The percentiles, because they are looking at ranking, okay, they are not that strongly influenced by extremes. And they also provide a good context for us to understand or to interpret the results. Remember, when we look at those normalized category indicator or journal indicators, you will get a number, say that it is 5 or 2, and you're going to say, my publications are 5 times better than the average publications in the field or in the journal. You can say that, right? But you're going to wonder, okay, so if I get 5, are there people who get number of 10 or 20 or 50? So how good exactly I am? We don't know. But when you look at percentile, you actually know where you are. If you are 99% percentile, you know you're at the top 1%. If you're the 95 percentile, you know you're at the top 5%. So you actually know where exactly you are. Okay, and it provides us with a very good context to understand and interpret the results. Okay, calculation, pretty straightforward. You need to have a defined reference set, and again, we would like to compare the same thing. So you would like to have publication within the same year, same field, and same document type. Okay, research articles have different citation rates than the review articles. So you don't want to compare research articles against review articles. Okay, so you want to have a good defined reference set. And once you have the publication set, you would like to rank them by the citations they received from the highest to the lowest. And then divide the citations into 100 equal parts so that each part will represent 1 percentile. Okay? And because many of the databases use invert percentile, so 99 percentile will represent top 1%, 98 percentile will represent top 2%. So what we're going to do is that when we find each of the percentile, we will use the lowest citation in that percentile as a threshold, okay, to find the number of the citations that you need to be ranked as that specific percentile. Okay, so say for example, here we know that from Article 1 to 10, this is the top 1%, and from Article 11 to 20, it is top 2%. It is in the case that if we have only 1,000 papers. Okay, so this is how we can do the calculation. And if you found that for the top 1%, the lowest threshold is 204, and for the top 10, the lowest is 52, things like that. This is just an example. I made it up. Okay. And when you find your paper, you will be able to see if your paper can be ranked as some of these things. Say that if you pull up your publications and you realized that you have 205 citations, then your paper can be ranked as the top 1% in the specific field within the same year. Okay, and if your citations is only 51, which is only 1 citation lower than the threshold, I'm sorry, you won't be able to be ranked as the top 10%, maybe top 11, 12 something, but no, not top 10%, okay? All right, so this is how we do this kind of calculation. There are a lot of challenges in doing percentile ranking. Okay, the first thing is about equal citation. So for 2 articles, 3 articles that receive equal citations, what do we do? Okay, generally there are 2 ways to do that. Sometimes people use the average rank. Okay, so they both are giving as a 3.5. Okay, or they share the same rank. They use 3, and then there is no 4. The next one will be 5. Okay, and how about articles that have no citations? Are we going to put them all together as 1 rank, or do we still put them all, calculate them all together, or exclude them at all? Okay, and how about articles that have multiple subject categories? Just an example. Okay, if I have an article called Why Do I Have to Know Citation Percentiles, and the journal is called NIH Library Journal, published in 2012. And that article is being indexed in 4 major subject categories, A, E, C, D. To do this kind of percentile analysis, remember that we'll have to pull up all of the publications in one specific area, subject category, within the same year for the same document type. Meaning that to get the percentiles of this specific article, I will have to do it 4 times for the 4 specific subject categories. What if I get different numbers? In one category, I might be ranked as top 10. In another category, I might be ranked as top 50 or below 50. So what do we do? Okay, literature has been pushing that we should use the average rank of these if there are different rankings in the field. But for the databases that we use for the Insights or Web of Science, what they do or what they provide is actually the one that has the highest rank. So if in the subject category A, I got a top 1%, and in other category, I got only top 10 or top 50, they're only going to show me top 1 in the field of A. Okay. All right. So it's a little bit biased. And you can also imagine that if we have to do this manually, it's going to be very time-consuming. You have to pull out all of the articles, pull out all of the subject categories in their fields in a specific year, specific document type, and then do the comparison. Okay. So in Insights, they actually provide this kind of information directly already. So they will tell you your specific research area, okay, and they will also tell you the percentile in subject area. And as I mentioned, they use the inverse percentile, so the smaller the number, the better. So here, 0.08, meaning that it's in the top 1%. Okay, it's a very good publication that received a lot of citations. All right. Okay. How do we use these percentile ranks? So in our report, you will see that we actually use 5 percentile ranks. We have a top 1, top 10, top 20, top 50, below 50. It's really very arbitrary. We just think that it would be good to show these different ranks. But you can decide the kind of classes that you want. You can have top 1, top 5, top 15, top 20, top 25. So anything that you want, you can do that. So it's very arbitrary, okay? And after that, we also show people, like in Essential Science Indicator category, how many of their articles are being ranked as top 10 and how many of the articles are below top 10. And here we show the distribution, top 1, top 10, top 20, 50, below 50. Okay, so generally a very broad picture about the distribution of their percentile ranks. Okay, so the next step is that how do we do that? Okay, you can get a file from Insights Benchmarking directly about each of the articles. Remember what I showed you earlier, that there's the article, and then there's the subject category, there's the percentile ranking. Okay, so all you have to do is just put it as like top 1%, top 1%, and then you can create your own graph. Okay, so you download the file and then look at the percentile and subject area, and then you build your chart. Very straightforward. Okay. In another part of our report, we look at the citation impact of individual authors. And you can see that there's a part about their citations. Okay, so again, this is straightforward to get their citations. There's another part when we show how many of their papers are being ranked as top 10% percentile, and how many of them are the below top 10% percentile. Okay, you don't really want to get to search one author by author and then to do the same thing? Okay, so how do we do that? Basically, when we do the co-author network analysis, we have a file from Gephi, and in the node table, you're going to get the citation count and publication count of all of the authors in the file. Okay, so you can use the citation count directly and then build your chart. Okay, and now you wanted to see how many of those papers in your data set are top 10 papers, and who produced this paper. Okay. If we can use the file from Insights directly, that would be great. That would be the perfect scenario. But remember, earlier in our earlier sessions, we mentioned that one of the limitations of the Insights is that they only display the first 5 co-authors in any of their files, meaning that if your articles have more than 5 authors, you're only going to see the first 5. The rest of them you won't be able to see. That creates a big challenge for us to use this file when we search these authors, because when you download the files, you have all of this information already, but you won't be able to see the complete list of authors. And your PI can be the last one because he is the mentor and it is not shown. When it is not shown, it won't be searched, you won't be able to find them in the file. Okay, so what do? We want to use this part and this part, the percentile part, okay, but we won't be able to use the names part. So in a way, we'll have to merge or to match 2 different metadata. Okay, so we need to use the benchmarking file from Insights. We also have to use the Web of Science metadata file so that we can get the complete author names, okay, for the top 10% papers. Okay, and once we get these 2 files, we sort of will have to match them. And I'm going to assume that you don't know how to match them. Probably you do, but I'm going to assume that you don't know how to merge these 2 files, okay? So we have to merge files. By merging files, meaning that we are going to merge the same articles, but for different fields. For the field that has information about percentile, I want to get percentile information to the same articles that have the complete author names. Okay, so the function that I'm going to use is VLOOKUP. Okay, and by using lookup, you need to have something that is unique that people can search. So I'm going to search by looking at their UT number, means their accession number. So each of the article in Web of Science has been assigned a number once they're being indexed, and these numbers are unique. So I want to use these numbers to combine the 2 lists. As long as the numbers are the same, I'm going to bring the percentile to the Web of Science file. Okay. So basically, this is how we use VLOOKUP. Okay. There is a cell that you would like to look for, and then you're going to give them a range for them to look up. And then if they find something that match, they have to return something, and there is a value you have to put in, and it's a column value, okay? And then you have to say it is false or true. False means that it has to be completely the same. All right. So this is generally how we use VLOOKUP. So what I'm going to do is something like this. And again, because we're going to use different files and we have different columns, the numbers can change. But I'm just going to show you the one that I used for the Fogarty research that we have shared earlier. Okay. So here we ask them to look at A2. That is the cell that has the UT number, okay? And then we want Excel to look at sheet 2. That has all of the information about percentile. And then to look at the whole sheet from the beginning of the cell to the end of the cell. And then if they find something that matches, okay, it means that if they found exactly the same UT number, I want them to return the 20th column, okay, the 20th column, and it has to be exactly the same, all right? So here, this is what I do, okay? So this is what I get from Web of Science, and this is what I got from the VLOOKUP. Okay, remember the Web of Science metadata doesn't have the percentile ranking information. We have to get them from insights. Okay, so once you brought that back, you're going to have something like this. Okay. All right. And now that you have all of the information here, what you have focused is actually the top 10% ones, right? Because you want to see who are the authors that produce these top 10% of a paper. So the first step is that you're going to sort so that you can find, or you can use filter so that you can just focus on the top 10%. And once you have these top 10%, you can just find the authors, and then you can build your charts. Okay, remember the charts look like this. Okay, you can find, say, for example, Schisterman. If there are 22 Schisterman in the top 10% papers, then he has produced 22 papers that can be that are ranked as the top 10% paper. All right. Okay, so this is pretty much what I would like to share with you and how we do for all of these things in our report about citation impact. If you have any questions, please let us know, and I'm going to log off for today. All right, thank you so much.